All right, hello geometry. This is going to be your notes on section 12.4. We are on page 8 today, so if you printed your workbook, find page 8 and you should be able to follow along. Otherwise, just do the best that you can to draw these figures and show as much work as you can in your notebook paper. I think today's lesson is a little bit easier than the one prior. Section 11.4 was on area of polygons, and that one's kind of challenging. You'll notice this one is volumes of prisms and cylinders. Volume is a little easier because for the most part, they have to give you all the information. You just plug it into the formula and you're done. So other cases, some problems can be a little trickier than others, so we'll work through them. The formula for volume of a prism is at the very top. Volume equals capital B times H. Now that seems really simple, right? But capital B has a lot sort of involved in there. Capital B is the area of the base, okay? And sometimes that can take a little bit of time to find, okay? Finding the area of the base was what we were finding in section 11.4, okay? So let's look at example 1. It says find the volume of the prism. Well, when you're trying to figure out what the base is, you have to think about sort of the two ends, okay? And the ends have to match. The shapes have to be exactly the same. So it's not going to be, even though it's laying on its side, the base is not going to be the rectangle here. Okay, it's actually a triangular prism where the bases are the two triangles and the height of the prism is the 25. So it's kind of like a Pringles can laying on its side. If a Pringles can was not circular and cylindrical, it would be a triangular prism. So it's kind of like a triangle can laying on its side. So the area of the base is going to be the area of a triangle. The area of a triangle is 1/2 base times height. Okay, the base of the triangle is the 10 that's given here, and the height of the triangle is the 12. Okay, so then if we multiply that together, 10 times 12 is 120, divide by 2, and that gets me 60. Now that's not my answer. That's just capital B. That's what's going to go in that section there, okay? So the volume is capital B times H, which is the height of the prism. I just found capital B to be 60, and the height is going to be my 25. And so if I do 60 times 25, I get 1,500. And because this time we're doing volume, my answer has to be units cubed. So it's 1,500 cubic centimeters. Okay? All right, let's try example 2. This one is a pentagonal prism. The top and the bottom are pentagons. Okay, so the base is a pentagon. And the height of the object is how tall the object is, which is going to be the 8 here. Okay, finding the area of the base is using the formula from 11.4, 1/2 times the apothem times the perimeter. Okay. Let's find the perimeter off to the side then. I'm told that this side here is 5 millimeters and there's 5 sides in a pentagon. So if I do 5 times 5, the perimeter of my base is 25 millimeters, okay? So the area of my base is 1/2 times the apothem times the perimeter. Well, we just found the perimeter to be 25. So now we have to find the apothem, which they give me right here. That happens to be 3.4, okay? So if I multiply that together, I get 42.5 millimeters squared. That's the area of my base, okay? Now, that is not my final answer. Again, I'm looking for the volume, so I have to find the area of the base times the height of the object. The area of the base I just found was 42.5, and the height of my object is how tall this present looking box is, so times 8, okay? If I multiply those together, I get 340 millimeters cubed. Okay. All right, hopefully this is not looking too difficult and you're keeping up with me. Let's look at the you try one. All right, this one is another triangular prism laying on its side. The base is this triangle here, or you can think of it as this triangle in the back, okay? The height is gonna be this piece here. So it's kind of like a triangle box laying on its side, okay? So the base is a triangle, and the area of my base is going to be 1/2 base times height, okay? Now, you'll notice that I have the base of my triangle, but I don't have the height of the base of my triangle. Be careful not to confuse this height with the height of the actual three-dimensional object. When we're finding the area of the base, you just want to focus on that one shape, which is the triangle. So ignore the rest of the picture and just focus on that one triangle. So anyway, you'll notice we have the base, but we don't have the height. Well, we do have this diagonal piece that's given to us in the back, which is 15, and I can carry that across to be this piece as well. So if you look carefully at this front triangle, we have a triangle where we have two sides, and it's a right triangle. So I can use Pythagorean theorem to figure it out. I'm going to mark that as A. So A squared plus 9 squared equals 15 squared. If you go through those steps, you should get that A is 12. Okay? So to find the area of this triangle here, my base is 9 and my height of the triangle is 12. Multiply those together, and I get 54 feet squared. Okay, now that's not my answer. Again, we're looking for the volume. Volume is the area of the base times the height. The area of the base I just found was 54. The height of the three-dimensional object is the 10. So I have 540 feet cubed for the volume. Okay. All right, let's look at the second page. So turn to page 9. Page 9 is going to be all about cylinders, which, to be honest, is probably the easiest one, okay? Volume of a cylinder is pi r squared times the height. You might recognize pi r squared. That's the area of the circle, okay? The area of the circle is the base, which is the base of the object here, okay? All right, so find the volume of the cylinder. Make sure to label the correct units and leave your answer in terms of pi. So I'll show you guys how to leave your answer in terms of pi. So we have pi times radius, which is 1.8 squared, times, so the radius is here, but then the height is also 1.8, which is that piece there. So I've got 1.8 squared times 1.8. Now, in order to leave this in terms of pi, do not, I'll take my pencil and I'll cover up the pi. Do not put pi in your calculator, and you can just do 1.8 squared times 1.8, okay? And that gets us 5.832, and then you can put the pi in your final answer. And this is in terms of centimeters cubed. Okay, so that is the volume of our cylinder, okay? For the next one, I'd like you to pause the video, try it, and then see if you can get the right answer. All right, so for the volume of this cylinder, notice they have a full line going across the circle here, the base of the cylinder. So that 9 inches represents the whole thing, which means my radius is half of that, which is 4.5. So I'm going to do pi r squared, which is 4.5 squared, times the height of the cylinder, which is 5. This is a cylinder on its side. It's kind of like, a can of soup fell on its side. So the height of the can is actually this piece here, okay? For this one, it doesn't specify to leave your answer in terms of pi, so let's just put it all in the calculator all at once. So I've got pi times 4.5 squared times 5. and I get 318.09, if I round to the nearest hundredth, inches cubed. Okay. Hopefully you're finding cylinders pretty easy because it's just a matter of plugging numbers in to a formula. All right, now there's something called Cavalieri's principle. What it's basically saying, I'm not going to read the words, you can read the words, but what it's basically saying is if a shape such as a cylinder is taken and then sort of tilted, you can still use the same formula because the space that's gone up here is taken over here. So basically they're just saying you can still use the same formula. So don't let the tilt of the cylinder confuse you. So pi r squared times h. The radius of my cylinder is 15. You can see it up here. You can see it down there. And then the height of my cylinder is given as 25. Okay. This one says leave your answer in terms of pi. So again, I'm going to take my pencil to cover up the pi. I'm going to multiply 15 squared times 25. And I get 5,625, and then you can go ahead and put the pi with it, and that's going to be feet cubed. Okay, that's pretty much the rest, or that's the bulk of the notes. The last part is just a summary, so these are just 2 extra practice problems. So let's go ahead and do those together as well. This right here is a trapezoidal prism. I'm not even sure if that's the right name, but you can hopefully see that the base down at the bottom is a trapezoid. The base at the top is also a trapezoid. So when we figure out the shape of the base, we then have to find the area of that base. Now, the area of a trapezoid, I'll go ahead and give it to you guys, is 1/2 times the height of the trapezoid times the sum of the bases. Okay, so I'm going to draw a picture of the trapezoid. I'm going to draw it separately for you guys. This little section at the top is 7. The longer piece at the bottom is given to us down here, which is 15. And then they give me the height of the trapezoid right here is 3. Okay, so if I find the area of the base, the area of the trapezoid, I have 1/2 times 3 times 7 plus 15 in parentheses. So if I type that all in my calculator, I get 33 for the area of my base. Okay, and that's in terms of inches. Okay. Now I want to find the volume. So I have capital B times H. The capital B I just found was 33. Then times the height of my object here. The height of the entire 3-dimensional object is 12. So I have to do 33 times 12. And so I get 396, and that's going to be inches cubed. Okay, hopefully that makes sense. All right, and then the very last portion says find the volume of the cylinder. Notice it's a review of Cavalieri's principle, so don't worry that it's tilted. You can still use the same formula. Pi r squared times the height. My radius here is 6, and the height of my cylinder is 12. We'll go ahead and type pi in the calculator. We'll get a little bit of practice with typing it in versus not typing it in. I get 1,357.17 if I round to the nearest hundredth. Okay. All right, that is 12.4 volumes of prisms and cylinders. So I hope you guys were okay with this one. Let us know if you have any questions. Obviously, because you have to know how to find the area of a base to be able to do these types of problems, make sure you know how to do 11.4. Really, you have to make sure you know how to do 11.4 and be strong at it in order to be able to do this section. So if you're struggling with 11.4, I would focus on that before you move on to this section. And of course, let us know if you have any questions. Thanks for watching, and we'll see you guys next time. Bye.